All right, here comes the second problem on page 418. It's number 24. It is a sister to your assigned problem 23, I believe. Yeah, I believe that's right. And now you can see I'm getting a little lazy because I've just left the figure up from the previous graph, which was this was for cotangent x. But let's just show how easy it is in some cases to represent these things, because while the amplitude in this case is associated with a 4, I'm going to end up attacking this problem in exactly the same way we attack this, only the scale on the sign that we're going to draw first goes from 1 to -1 down here, okay? Then the other thing that's different here, of course, is the period of this function. The period is always 2 pi over omega. This is omega. Omega equals pi over 4 in this case. So the period is equal to 2 pi, all divided by pi over 4, multiply top and bottom by 4. And you see that the period is 8. So that means that this number here, which was 2 pi in this case, is now 8. It is 1 period of the sine, yeah, which makes this number 4, this number 2, this number 6. And let's just put some of these down here: 2, 4, 6, 8. You know, and let's just check that then. If I wanted to draw sine, not of sine x, but rather if I wanted to draw sine of pi over 4x, then let's see if I've done it. When x is equal to 8, the sine of 4 pi over x, when x is equal to 8, is sine of 2 pi. And indeed, we're back to 0. If I put in 2 here, I'm talking about the sine of pi over 2. And sure enough, this is what the function sine of 4x over pi looks like. Here is the cosine of 4 pi over x. Here is the tangent of 4 pi over x, pi over 4x. And here is the cotangent of pi over 4x. Just that simple. Just that simple. So let's call this the solution to problem 24 and continue on.